welcome to the fourth video in the circles topic at higher maths. What we're going to look at today is lines of intersection and proving tangents. Okay, so two things to take from this video: being able to find all the points of intersection between a line and a circle, and be able to prove that a line is a tangent to a circle. Okay, so here's just a quick example. You could put this in your notes if you wanted to. It's entirely up to you. The next example will cover it as well. We're looking to find the points where the line intersects a circle. Okay, now just with any points of intersection, what we're doing here is we're going to use simultaneous equations. We want to solve them simultaneously. Now, with straight lines, and parabolas, what we tend to do is y equals, and make them equal to each other. The squares make that very difficult though. But what we can do is substitute in. So we know that y is equal to 2x plus 6. So everywhere we see a y, we can replace it with 2x plus 6. So x squared plus y squared, which is actually 2x plus 6 squared, plus 2x plus 2 lots of y. Well, it's not y anymore, it's 2x plus 6 minus 8 is equal to 0. Okay, you can see now we've substituted in and we no longer have any y's. Okay, the next 2 or 3 lines are all going to be nat 5 stuff. Okay, but what you need to do is you need to be very careful when you're multiplying out the brackets and when you're working with negatives and so on, just because you don't want to lose any draft marks. Okay, so I'm just going through that, multiplying out brackets. I'm not going to go over that. That's just what it becomes. So when we simplify it further, it's 5x squared to 4x 26x plus 30x, and then 36, 48, subtract 8 is 40. Okay, now the first thing I do there, because it's an equation equals to 0, I divide both sides by 5 and get rid of that 5 at the start. That's going to make it nice and easy to factorise. So x plus 4, x plus 2 equals 0. Notice that after that initial circle work, we're actually just doing that 5 stuff now. So x is equal to negative 4, x is equal to negative 2. Okay, now we're looking for points of intersection, not just looking for the x coordinates. You can substitute back into either. For the life of me, I don't know why you would pick this one. I would pick just the first one. Y is equal to 2x plus 6. So when x is negative 4, y is equal to 2, negative 4 plus 6, which is negative 2. And when x is negative 2, y is equal to 2, negative 2's add 6. Negative 4 add 6 is just 2. So your 2 points of intersection is negative 4, negative 2 from the first strand. And from the second strand is negative 2, 2. And that's you done. Okay, now that's how you're going to solve it, just like you would solve any point of intersection using simultaneous equations. And in reality, because you're working with squared, you're always going to get a quadratic. And because you've got a quadratic, you've got 3 options, just like you did with discriminant earlier on in the course. You've got 3 options, or even in that 5. You're going to get one answer. And b squared minus 4ac is equal to 0. You're going to get 1 root. You're going to get 2 roots, but they're both the same. You're going to get no answers when there's no roots. And you're going to get 2 answers. And your discriminant is greater than 0. You're going to get 2 roots like we have here. Okay, now no roots means there's going to be no points of intersection. Okay, you're just going to have a circle and then the line flying by it. 2 roots are just like we have here, where it's just going to cross it at 2 places. And 1 root's probably the most interesting. That's where you're just going to touch it in 1 place, which we know as a tangent. Okay, and we call that the condition for tangency. If you get to this stage here, either this line or this line, because they're both essentially the same, and you have 1 root, then you know you have to have a tangent. Okay. Now, That's just what that's saying, and I want you to get that in your notes. Okay, so this is going to be in your notes chart. Okay, and that comes from your discriminant. Okay, so no roots when b squared minus 4ac is less than 0, 2 roots when b squared minus 4ac is greater than 0, and exactly one repeated root for a tangent when it's equal to 0. Okay, and I'm just going to give you one example, then leave you with two more. Okay, so if you've not got that down yet, sorry, just get that in your notes. And then this is example one also for your notes. Okay, we're proving that the line is a tangent. Okay, we want to show that it's only got one point of intersection. So we're going to substitute in y is equal to 3x plus 10. So everywhere we see a y, and it doesn't have to be y, I've just used y because it's been given to me. If it was x equal to 2y minus 5, just use that as instead of x. So let's subtract next. Let's get rid of that row add. Minus 4y minus 20. Okay, making mistakes all over the place. I don't want the y. I'm taking that out and putting in 3x plus 10. Oh, sorry. I messed that up. I'm just going to go back there and start that again. Apologies. So it was minus 4y, but the y we're going to replace with 3x plus 10. And then we're subtracting 20 equals 0. Next bit is all just national 5, breaking brackets. Break that squared. You're going to get 60x plus 100 minus 8x. Careful, that negative 4 in front, so it's going to be negative 12x minus 40 minus 20 is equal 0. That's quite long, obviously, but just take your time, be careful, make sure you don't make any mistakes. 10x squared plus 40x plus 40 is equal to 0. Because you've got it equal to 0, just divide by 10 both sides, because that's a common factor. Is equal to 0. Now, in reality, you've got two options here. Okay, at that point, you've got your quadratic. You could check b squared minus 4ac equals 0, and that's a big proper way to do it. So 4 squared minus 4. Actually, you don't know if it's equal to 0, you're checking it. So again, a couple, too many mistakes. B squared minus 4ac is 4 squared minus 4 times 1 times 4. That's 16, that's 16, so that's equal to 0. So b squared minus 4ac is equal to 0. Therefore, repeated root. And line is tangent to a circle. Okay, so that's your big proper way of doing it. Okay, your alternative though, and this is because you're not just asked to prove that it's a tangent, but you're asked to find the point of contact as well. You're going to factorize this anyway. X plus 2 is equal to 0, which solves for x equals negative 2 and x equals negative 2, which is obviously the same. It's obviously a repeated root. So if you wanted to, instead of finding the discriminant, you could go to here and then just come straight across into the repeated root stuff. Okay, as long as you're making that statement about, well, I know it's a tangent because of this. Okay, and then find the point of contact, x equals negative 2, you know y is equal to 3x plus 10. So y is equal to 3 negative 2 plus 10, which is 4. Okay, so your point of contact is negative 2, 4. Okay, so that's your kind of working for that. You sub it in as if you're finding that point of intersection. You prove that you're only getting one answer, whether that's through the discriminant or through just carrying on and getting a repeated route. Make your statement and then find your point of contact. Okay, and just lastly, I'm going to leave you with two more examples. Be careful here. Obviously, you don't know what y is equal to or x is equal to in either case. You can rearrange for any, whether you want x to equal or y to equal, whatever seems more appropriate to you. Give those two a try and let me know if you've got any issues. Thank you.